All right, here we go with lesson 10.4. We are going to introduce secants and tangents in this lesson. So we got some vocab, again, more things we want to make sure we are familiar with and we know what these words mean when we see them throughout the chapter and upcoming chapters. A secant is a line that intersects a circle at exactly 2 points, and then every secant contains a chord. So if we look at this picture over here, the secant is going to be the line that's intersecting at 2 points. So I'm going to go ahead and trace. We're talking about this line right here. First of all, it's a line, so you have arrows on both ends, and then intersecting at 2 points. So it's intersecting here and it's intersecting there. Now, so that's a secant, basically a line that intersects a circle, but it does have to intersect at 2 points, and it will contain a chord. So if I were to connect the 2 points within the circle, that's the chord that lies within that secant. So that's what that part of that definition means. A tangent is a line that intersects a circle at exactly 1 point, and we call that the point of tangency or a point of contact. So let me show you or talk about that, and then we'll finish that definition. So here's our tangent line, and you can see it's not crossing through the circle like our secant line or our secant did. It is a line, so it has arrows on both sides, and if we were to zoom in really close and look at this, we would see that it's only touching the circle right there. It might look like it's touching it more than that, but technically it's not. And then another part of the definition is that a tangent line is perpendicular to the radius drawn at its point of tangency. So remember that point of tangency is the point of contact. So if I draw a line, excuse me, from the point of contact or the point of tangency to the radius, it's going to go right there, that is going to create a perpendicular angle. So we've got 90 degrees right there. So secant, it crosses through it. You got 2 points on the line. A tangent just touches it on the edge of the circle, and it gives you 1 point of tangency. And if you connect that point to the radius, you've got a right angle. All right, so now we have tangent and secant segments. So if we're talking about just a plain tangent, automatically it's a line. That's part of the definition. But we have something called a tangent segment. So a tangent segment is the part of a the part of a tangent line between the point of contact and a point outside the circle. So if we look back at our picture here, here's the point of contact, here's the tangent, and then a point outside the circle, and so it's connecting those two. If I were to continue that segment I drew and in both directions to put arrows, then it would be the tangent, which is a line, but you can have a tangent segment where you have endpoints. Secant segment, same idea, that definition, the part of a secant line that joins a point outside the circle to a farther intersection point of the secant and the circle. So what we have going on here, that sounded really wordy, probably because I didn't read it all at once. So remember a secant, if I were to draw the secant, it would be the line that crosses through the whole thing, and it's just going to continue in both directions. As soon as I say a secant segment, I'm going to take one endpoint on the circle, and the other endpoint has to be outside of the circle. So I have to cross through the circle so I'm on the outside, and there's the other point. That's a secant segment. We don't want to have, we can't call a secant segment if we were to put the other endpoint on the edge of the circle right here, because then that would just be a chord and we'd call it something else. So that's why a secant segment goes all the way through into the outside of the circle, and there's your other endpoint. All right, we've got this great theorem called the two-tangent theorem. It tells us if 2 tangent segments are drawn to a circle from an outside point, then those segments are congruent. So here's what this is going to look like. if I have a point outside the circle, let's just say I put one right there. Now I'm going to draw two tangent segments. So a segment means the other endpoint will be on the circle. Remember, the tangent is just going to basically touch the edge of the circle. So there's one tangent segment. Now if I draw another tangent segment to the other side of the circle, it's going to touch right there. What the theorem tells us is that this segment is congruent to this segment. So two tangent segments that share this endpoint over here, those will be congruent. All right, we also have these things called tangent circles. These are circles that intersect each other at exactly one point. Well, this can happen two ways. You can have them be externally tangent. So what that's going to look like is you're going to have a circle, and the other circle is going to be outside or on the external side of this. So if I draw another circle, it's only going to touch in one spot because of the word tangent. So let's say it's touching right there, and I draw another circle. So you see how they're touching right here, but they are, the one circle is on the outside of the other circle. So that's externally tangent. Now internally tangent, if you have a circle, and then the other circle, it shares just one point. So let's say that's the point that they share, but this second one is going to be on the inside for internal. It's going to look something like that. So that's internally tangent. Again, we see the word tangent. We want to know that they only touch in one spot. So in this case, that's their point of tangency. And over here, this is their point of tangency.